Diagram 4 shows the apparatus setup of an experiment to determine the empirical formula for oxide of copper. Now, in previous question, like question 7, we also have the experiment, which is also from chemistry. The one is magnesium turned to magnesium oxide. You heat the magnesium with oxygen, then it becomes oxide of magnesium. But this question, you don't start with copper. Now, for copper, you start with copper 2 oxide, CuO, burn with hydrogen gas, they become copper, turn back to copper, and water. This method is a bit different. But at the end of the end, it's all the same. They just want to determine the empirical formula. We just that they are using different way because for the previous question, for the crucible one, magnesium react with oxygen one, you cannot use copper because copper is too unreactive towards oxygen, very less reactive. So that's why in this case, for copper, it has its own experiment. So in this case, now what you can do is, normally at the left side is water, right side is the zinc granules together with the acid. Now these two, very simple. These two basically, when you react together, when you put together zinc and hydrochloric acid, you will get zinc chloride, but it's not the most important thing. The most important thing is hydrogen gas, H2. You want to obtain H2 so that when the H2 come up from this reaction, then only it can meet the CuO in the middle, which is black color, by the way. Okay, then only CuO can react with the hydrogen gas that produced from here. Then you might ask me why you have water here. Now water, actually this experiment is just to absorb the excess hydrogen. Not absorb hydrogen, sorry, absorb oxygen. Because this experiment, you don't want any oxygen because the aim is to have hydrogen. So you have to force before you heat, before you use the spirit lamp to heat, you have to force the oxygen gas out of the way. Remove the oxygen gas from the glass tube. That's why, how do you remove? You remove into the water. The water, you absorb the oxygen gas. Okay. Even during heating, you have to let the entire hydrogen gas flow through. Why? Why do you have to do this? Because especially if you left any oxygen gas inside, it will burn, it will explode. Because hydrogen react with oxygen, especially in hot air, then it will explode. It will catch fire, very dangerous. That's why we have to avoid oxygen in this area. Okay, even after experiment, you still have to let the hydrogen gas flow through because one thing, after experiment, easily the CuO already turned to Cu. So in this case, you don't want let's say if you after experiment you let the oxygen straight away enter because after experiment the copper is still hot. It means if the oxygen gas simply enter, it's very easy to react. Then maybe some of the copper will go back to CO. Do you want this to happen? No. So in this case, you only want the final result, which is Cu. So you have to prevent the copper is being oxidized by the air to turn back to CO. So then, if they ask why you have to use spirit lamp, which inside fill ethanol, number one, spirit lamp have the flame is smaller. So because notice this glass tube is so thin, so if you use Bunsen burner, which the heat energy is higher, it will just make the glass tube explode. Not say explode, but it will break the glass tube. The glass tube cannot tahan the heat. Okay. Second, you must have ethanol. Ethanol is your alcohol. Reason, because ethanol is a clean fuel. Meaning, if you use Bunsen burner contain alkane, right? Alkane, like butene and propene. So that field is a bit dirty in terms of you will get the black color soot. Meaning, if you use Bunsen burner, you blacken the glass tube, which you don't want this to happen. Okay, because ethanol is a clean field, meaning it won't produce any soot. It won't blacken the glass tube. This is they are the few precautions. Okay. Hydrogen gas is flow through the glass tube before heating is started. Before started heating, you have to let the H2 to flow. Reason, just to remove the O2 from the glass tube. Remove the air, you can say remove the air, you can say remove the oxygen gas, also can. Later, if no, it might explode, dangerous with the heat. Role of zinc granule and hydrochloric acid in this experiment. I told you, right? This experiment, because hydrogen gas won't suddenly appear out of nowhere. So that's why in this case, you must have these two so that you only can obtain your hydrogen gas. Write the equation for this. So remember, the Mg1, the crucible in the question 7, this one is metal turned to metal oxide. But, and this one is react with oxygen. The mass probably will increase. Magnesium like 24 gram, maybe magnesium oxide is 26 gram. So increase. But this one, no, CuO turn to Cu means the mass will decrease. From metal oxide, react with hydrogen gas, become metal. So CuO react with hydrogen gas. Now, because hydrogen actually is more reactive than copper. More reactive than copper, then the H2 can rampas Cu punya O. It means, let's say, Cu and O, they are partners. They were partners. So what happens? Then H2 rampas Cu punya girlfriend lah. Rampas away because H2 is smarter, taller, looking better, stronger, okay, more power. So that's why now it become H2 become H2O, Cu will become single. Okay. You must be, do I have to balance? No need, because it's already balanced. Because Cu is 1, O is 1 each side, H is 2 each side. So settle. State an observation in the chemical equations from C. Now, just only I tell you, I told you that copper 2 oxide is black color itself. So after heating, the black color turn to the copper. Copper is brown color. So I have to say the color changes, which is black solid turns to brown. In Malay is hitam menjadi, pemecah hitam menjadi perang. Move on. Name another oxide of metal which the empirical formula can be determined by using the same method as shown in diagram form. So let me write down this one. So let me write down the reactivity of metal. Now, in this case, hydrogen is between zinc and iron. So normally the top 3, we don't do experiment because it's too reactive. Okay, but I think calcium can burn with oxygen to get calcium oxide. But normally, this 3 is too reactive, easy to get exploded. So that's why normally you start with magnesium. Magnesium, aluminum, and zinc. It means these 3, right, you react with oxygen to become oxide, right? So, but in this case, let's say your experiment, you don't have magnesium. So you can change to aluminum or zinc. Both have the same reaction. But below one is less reactive. So that's why it's not so suitable to burn in oxygen. It's a bit hard to react. So that's why in this case, normally what I do is the bottom one, like iron, like tin, like lead, like copper, like silver. Now instead this one, now you have to use the oxide. All these you have to use the iron 2 oxide, tin 2 oxide, lead 2 oxide, copper 2 oxide, silver oxide. This one, all you have to burn with hydrogen gas. They only turn to the single one. Like that. Yeah. So, any one of these answers are accepted. Okay, because there's us, name another oxide, right? Here we already got the copper 2 oxide. We already got the copper 2, I mean the copper oxide. So other than copper oxide, either one is accepted. But I don't recommend iron 2 oxide. So the best I would say tin, lead, or silver. Because they are more like bottom, right? I recommend either three. Table 4 shows the result of an experiment obtained by a student. So you can see lah, the empty glass tube is 9.25 gram at the beginning. Before you start with anything, just empty glass tube. After you put the copper 2 oxide into the glass tube, then it becomes 9.35 gram. After you burn, you heat, then you become CuO, becomes Cu, right? So in this case, notice the mass decreases, become a bit lighter because then the oxygen has been lost. So it become a bit slightly lighter. Calculate the mass of copper and oxygen. Same, but you have to be careful. Not always like the question 7, 2 minus 1, 3 minus 2. No, in this case, look carefully. If you want to find the mass of copper, the Cu, now you have to use, let's say you got 1, 2, 3. So you have to use 3 minus 1 in this case. Glass tube minus glass tube 0, then you will get copper. So you use 9.33 minus 9.25. Which you will get. And so you have to state out, if they didn't give you like copper or oxygen, you have to state of mass of copper equals like this. To tell the examiner, is it you're calculating mass of Cu or mass of O? You have to state for them. Which you will get 0.08 gram unit important. Then oxygen, actually you have to use 2 minus 3 in this case. How? Glass tube minus glass tube, copper minus copper, then I get the oxygen. That's why I use 9.35 minus 9.33, which I will get 0.02 gram. Calculate the number of mole of copper atom and oxygen atom, and then determine the empirical formula for the oxide of copper. This one is the easy 3 marks in the pocket. So in this case, you just have to know the formula. Number of mole equals to, and bilang mole equals to Gsim over Gsim in Malay. Okay, in English, number of mole equals to mass over molar mass. So they want to calculate for both copper and oxygen atom. Only atom, even if they ask you in like a one package straight away, sometimes they ask only one question but contain 3 marks. 3 mark, maybe 4 mark. Okay. Find the empirical formula of this. Then you can just draw a table. The element, mass, number of mole, simplest ratio. Okay. Then contain like CuO, how many gram, number of moles. Then you divide the small number. Okay, so but in this case, very simple. Straight away can divide. For Cu1 is, since you got 0.08 gram, okay, then for molar mass for Cu atom is 64. So you just divide. You will get 0.00125 mole. Now, in your calculator, you might see this sometime. Actually, it's the same thing. So what happens? You learn in mathematics. This 10 to the power of -3 means divide by 1000. So because 10 to the power of -3 means 1/1000 actually. Or you can say 0.001. It means you multiply this. Or you can say divide by 1000. Same meaning. So you just move move the decimal place 3 times. You move to here. Then instead you will get 0.00125. Same thing for O, 0.02 gram divided by 16. You also get the same amount. It means, isn't it the ratio Cu to O? Isn't it, as you can see, isn't it 1 to 1, right? So that's why the empirical formula is CuO.